Thank you for tuning in to yet another episode of Watermark Equipment Tips. Laith here. This week we're going to be discussing some of the different timer modes that you guys are used to using on your process control equipment. Now, a lot of people use these timers differently, so I'm going to just kind of give you the rules of thumb that I have seen. Disclaimer, I'm not a chemist. I'm an equipment guy. So let's go into the different timer modes that you may be using on your equipment. So the first group of timer modes we're going to go over are the ones you use for your probe readings. So if you've got a conductivity controller for your cooling tower, you set that up. There's a couple things you define on it. It's either a rising or a falling set point type. What that means is if it's a rising set point type, your relay is going to turn on when you exceed your set point. So the value from the process is innately rising. It's going to rise above your set point. Your relay is turning on to combat that and get it back below your defined set point plus your differential. Now, if it's a falling set point type, you're doing the opposite. You're waiting for your value to fall below whatever your set point is. Once it does, you then turn on a relay to combat that. You could be turning on a pH pump. It's fallen beneath a value. You need to feed a base, an alkali, to get your pH above a value. Or you could be using like a PTSA timer or PTSA probe to keep your PTSA, your trace, above a certain threshold so you have enough inhibitor in your process to keep it under control. With a set point control mode timer, where you define rising or falling, you also have to define the set point that I mentioned, a differential. You can define a limit alarm. I recommend this on any relay that's feeding product. If you've got set point control mode set up with a PTSA probe and your feeding inhibitor, you would not want something to happen to your probe reading, or somehow you have flow maybe and the probe might be drifting. It could cause you to overfeed and potentially dump a whole chemical drum into your process. So make sure you define a limit timer so that the pump will only turn on for an hour and a half, 2 hours, however long you think the maximum time it should ever organically see in the process. Once it exceeds that, it turns the pump off. Make sure you select turn relay off once your limit timer's hit. Then you can also define high and low alarms. So if your value is outside of those bounds, the controller goes into alarm as well. On an online controller, when it's out of those bounds, it could email you, notifying you that that parameter is out of range, and you can implement corrective measures. Other timer modes would include percent timer. Percent timer is define a time span and define a percentage of that time. 10% of 10 minutes means the pump's going to come on for 1 minute for every 10 minutes. And it just does that indefinitely unless you have a flow alarm or something. Pulse timer is another common one where you have a water meter tied into your controller. The water meter could be sending a pulse. So let's say you've got a 10 gallons per contact meter. You might say for every 100 gallons that comes through, turn on my pump for 15 seconds. You would define that using the pulse timer. Percent of post bleed means that once you turn on your bleed relay, you are then counting how long is that relay on. Once your bleed concludes, you take that time and then feed a relay for a percentage of that time. The only other timer mode I'm going over in this video, by no means completely comprehensive, is the 28-day timer. 28-day timer is basically a 4-week block where you can define weeks and days within that weeks for a timer to do something. Very commonly used for biocide feeds. Typically linked into a 28-day timer would be bleed control, i.e. before a 4-hour duration of biocide feed. You would pre-bleed a tower for a defined amount of time or until you hit a certain conductivity minimum. Then you would feed your oxidizing biocide, and then you would lock out bleed for a certain amount of time. Locking out bleed is going to allow that oxidizing or not oxidizing biocide to circulate within your system to give you an effective kill on all the bacterial microbial life that may be in there. If you didn't do a bleed lockout, then there's a chance that you could feed product and then it goes straight to drain and you don't get an effective kill. Anyway, that's just real brief on some of the most commonly used timer modes on your process control equipment. If you have any questions, that's what the comments below are for. Hopefully you learned something. See you guys again soon. Thanks.